Hi, so I got this question from a classmate, and it's question number 25 on the balancing equations worksheet. And when you look at the answer, the coefficients are quite large. That kind of shows you that it's a bit more of a complex solve than normal, but not unsurmountable. First of all, I've already gone ahead and I have calculated the number of carbons, nitrogens, hydrogens, and oxygens on the reactant side and also on the product side. Once you've done that, you always want to leave your oxygen and your hydrogen to balance until the end. It just makes it easier. And I have carbon and nitrogen are the ones that I'm going to balance first. And I'm actually going to do nitrogen before I do carbon, because if I were to balance the carbon first and then went and balanced the nitrogen, this balancing of the nitrogen would change my carbons up anyway. So I'm going to start with my nitrogens. And I have 3 nitrogens on my reactant side and 2 nitrogens on my product side. Whenever I have numbers which are just a single number off, I like to use the multiple method. Basically, that means is you think of a number that both 3 and 2 go into, which in this case, the lowest common multiple is 6, and that's what I'm going to bring my nitrogen number to on each side. So on my reactant side, in order to have 6 nitrogens, I'm going to put a 2 here. That's going to raise my carbon count to 14, my nitrogen count to 6, which is what I want. My hydrogen count will be 10. And then my oxygen count I have to be careful of because I have 6 oxygens here and 2 here. So 2 times 6 gives me 12, plus 2 will give me 14. Whoops. So 14, like that. Then on my other side, to get my nitrogen count here to be 6, I'm going to multiply my nitrogen by 3. And that changes my nitrogen to 6. So I have my nitrogens equal now. Now I'm going to go back and I'm going to balance my carbons. So I see that on my reactant side I have 14 carbons, so that means I'm going to need a 14 here as well. That's going to change my carbon count on my product side to 14. It's also going to change my oxygen count. I have 14 times 2 oxygens give me 28 oxygens, plus 1 here is going to give me 29 altogether. So first of all, I have balanced my carbons and my nitrogens with that. Now what I have left to do is to do my hydrogens and my oxygens. So for hydrogen, I see that I have on my reactant side, I have 10 hydrogens, and on my product side, I have 2 hydrogens, and it's very simple to put a 5 in front of my H2O here to get my 10 hydrogens. So I'm going to go ahead and do that. So that's going to change my hydrogen count on my product side to 10. It's also going to change my oxygen count. So altogether for my oxygens, I have 14 times 2 is going to give me 28, plus my 5 is going to give me 33. So my new count for oxygen on my product side is 33. With that change, I have balanced my hydrogens. Now all that I have left to balance is my oxygens. So in order to balance my oxygens, I have 33 on my product side and 14 on my reactant side. So I have to bring this oxygen up to 14. Now my oxygens are split between 2 compounds, this gaseous O2 and then inside this compound here. So one of the things that I'm going to do first is figure out how many I need altogether. So I know I need 33 altogether. I have 2 times 6 here is already accounted for, so that's 12. 12 oxygens are already accounted for in this compound here. So I am going to get rid of that. those 12. So 3 minus 2 is 1, 3 minus 1 is 2. So that means I have 21 left over, and I have to make up those 21 right here. So what number times 2 gives me 21? That number is 10.5. With 10.5, I will have 33 altogether as the number of oxygens on each side, because 10.5 times 2 gives me the 21 I need to add to the 2 times 6, which is 12. So 21 plus 12 gives me 33, and now my oxygens are balanced out. But I know your alarm bells are going off because you cannot use a decimal as a coefficient. So we have to fix that. So I can put a decimal in the interim as a coefficient, but I do need to correct that. And the easiest way to correct that is to multiply 10.5 by 2, and that's going to give me my 21 right there. But if I'm going to multiply 10.5 times 2, I'm going to need to do that to every single coefficient in the whole equation. So that's going to, get my eraser, that's going to change this to 2 times 2 is 4. We already did 2 times 10.5 is 21. 2 times 14 is going to be 28. 2 times 5 is going to give me 10. And then 2 times 3 will give me 6. And then there you go. When you go through now and count the number of carbons, nitrogens, and hydrogens and oxygens on the reactant side, and the same for the product side, you will see that by multiplying all the coefficients by 2, we not only get whole number coefficients, but also all of the elements balance out. So that's how you do a more complex type of balancing equation, remembering that you want to leave hydrogen and oxygen until the end. You want to make sure that you count oxygens that are separated, or elements that are separated between two compounds. Make sure that you identify those and work through those appropriately. And lastly, if you need to put a decimal in as a coefficient, that's okay. Just remember to fix it or correct it at the end by multiplying every other coefficient by the same number that you multiplied the decimal by in order to create a whole number. So I hope this helps. This is one of the more complex problems that you will see, and there will only be maybe one on the test that's this complex of a problem. So please don't worry about that, and I thank you for watching. Bye for now.